Okay, before I start, any question? Any question from the previous notes? Okay, if not, I have a question. Did I mention about homomorphism and isomorphism before? Yes or no? For this chapter, I think I forgot to include homomorphism and isomorphism. Yes or no? Yes, no? Tak ada jawapan pun. Did I mention about this? Just look at your notes for this chapter. Okay, I want to hold these two subtopic. Okay, so that's good. That's what I think, right? Because this is the last topic. Now I want to go to this topic because okay, for homomorphism, let G be a group let G and H be groups, and Phi is a mapping from G to H. Okay, let G and H be groups, and Phi is a mapping from G to H. Then Phi is a homomorphism if, okay, when I say G has operation, yeah? G has the operation and H has an operation. If for all G1, G2 in G, Phi of G1 G2 is Phi of G1, Phi of G2. That's it. That's homomorphism, yeah? So that means there's a mapping. I didn't say function, I say mapping, just a mapping. This is group, yeah? It can be matrices, it can be numbers. Once I said groups, then you say, okay, close, identity, inverse. Close means you have G1, G2, and G is under star, H is under hash. So if there is a G1 and G2, it's close. So G1 star G2 is also inside, right? G1 star G2. Where's my view? Okay, I make sure my view is okay. Saya dah tanda merah-merah ni, so I don't write macam silau kan. Okay, so phi, if there is a G1, there is a phi G1. If there is a G2, there is a phi G2, right? If there is a close, this is another element inside, right? And there is also the image. Okay, it's a homomorphism if this image is actually the product of these two. Yeah, this image is actually the product of these two. And the product here, because it's already in H, it uses H operation. Okay, that's why the homomorphism said this is actually this times this. This is equal to this times this. So this is what it means by the homomorphism. You move from the G part to the H part. All right. So I give some examples in the notes. You can go through. Okay, we go back to which is it? Because I want to say about groups, but if I change this to not groups, like in the notes I mentioned after semi-group, right? Or after monoid, okay? So it can be semi-group, it can be monoid, but normally people talk about homomorphism and isomorphism between groups, okay? So in that definition, I mentioned about semi-groups, okay? As one example, okay, I don't want to. Okay, so we have changed to F. I follow the one in the notes, yeah? And you will be given the mapping. If you're not given a mapping, to show it is isomorphic later, I mentioned about isomorphism, or homomorphic, you have to come up with the mapping. But you can come up with 33 different mappings, so I will give you a mapping. Okay, now the question can be, just this, given this one, show this is a group or semi-group. This is a semi-group, it's not a group, right? Because there is no identity, right? Under this is okay. This is also not a group. It's a semi-group, right? Because this is even number, 2, 4, 6, 8 under multiplication. But I just want to show the homomorphism part, yeah. Okay. First question can be decide whether it's a group. It is not a group because this has no identity, right? There's no identity. Start with 1. Identity under addition, if it's just number, regular operation, the identity has to be 0. Not in, but doesn't matter. We're talking about semi-group. Okay, so you have to write this. F of G1 plus G2, okay, because this is a plus, use this. So this is 2 to the G1 plus G2, because the formula, which is equal to, because of the operation index, right? This is F of G1, F of G2. Now it's a cross, right? Which is this. Okay, so the the mapping is a homomorphism. Okay. Right. Is it okay? The calculation is not that difficult, but you have to know how to use the operation. Okay. No, not okay. Okay. I will give you another one. Example 2. Example 2. Dari example 1, example 2. F is from R plus to R plus Fx is x squared. Okay, so you look at this. Actually, this is a group. This is a group, right? All right. So you will see f of, you can use x or y, doesn't matter, but I just use g1 plus g2. You can do like this first, just to make sure what you want to show. Is it equal to f of g1 plus f of g2? Okay, I put this because I want to see or prove whether they are equal or not, right? I put a plus because it's a plus. I put also a plus because this is a plus. And then you take the left-hand side. And then you put what is f of g1 plus g2 inside the formula. Okay, so instead of x, we have g1 plus g2. So this is g1 plus g2 squared. And the operation is just the simple algebra, right? This is equal to g1 squared plus, don't forget the middle part, g1, g2 plus g2 squared. And then you start. You want to show that this is equal to this. You don't have to go from the left to the right. You can start from the left equal this, and you go on the right. You can start from this one. Then you can show using this. This is g1 squared plus g2 squared. So are they equal? Yes or no? No. Yeah? Giling, giling, giling. They are not equal. So they are not equal. So you can write another sentence, or you can write this is not equal here. This can be your kata conteng, yeah? This can be your draft, but you can write therefore they are not equal, or you can just write this is not equal to f g1 plus f g2 because that one is equal to this one, right? Because however you write it, I can accept, just to make sure that they are there. So you can start from the left, equal to the right, or you can start from the left, stop. You can start from the right, stop, and show they are equal. Okay, the best mathematical way is to start from the left and show it is equal to the right, or you start from the left and show it is not equal to the right because the right is equal to something else. Okay. Another question is, so don't forget to write the answer. F is not a homomorphism. It's not a homomorphism. Okay. The other example that you can find from internet, any books, don't limit yourself to the one that I give in the notes. Okay, and also do the exercise. All right, the next one is I want to show that it's a homomorphism. Oh, sorry, isomorphism. So an isomorphism is a homomorphism which is one-to-one and onto. Okay, it's one-to-one and onto. Wait, I change the view. I changed the view. What happened to my, oh, okay. Oh, hiding. Okay. All right, so for isomorphism, it's an isomorphism if it has three properties. The first one is it's a homomorphism. The second one is it's one-to-one. The third one is in onto. So we say phi is an isomorphism from G to H. Normally I use for groups, but you can use for semigroups or monoid. If it is the homomorphism, I put this again. One-to-one, phi of G1 equal phi of G2 imply G1 is G2. This is one-to-one, right? This is one-to-one. And for onto, for all H in H, the exists G in G map to H. Okay, for all H in H, there exists G in G such that phi of G is H. Okay, so you have to know how to show it is one-to-one or onto. Okay, back to the function that we discussed before. Yeah. So for all H in H, there exists a G map to H, meaning H has to be an image. All element in the right-hand side has to be an image to be onto. And one-to-one, you cannot go from two different one-to-one, right? You have to go from two different one to two different one. Okay, so I have to give you one example. Then I have to go back to the last part, which is normal subgroup. And I just give you this example. Okay. Let me see. Just now I give you this, right? F, the first example I give you, what is it? Z plus, plus, right? Plus E plus cross, what? Fx, say, this can be changed to any number. It can be E to the X. Okay, E to the X. So you cannot forget the functions that you learn in your first year or a high school or secondary school. Some basic graph that align, quadratic, cubic, right? Big W to the 4, right? To the 4. Because this is not 1-to-1, not 1-to-1, not 1-to-1. It's 1-to-1, right? This is onto. This is not onto because the Y underneath is not mapped to. This is onto because it covers everything. This is not onto because it doesn't cover down there. So remember how you do 1-to-1 and onto also from graph. For this particular one, right? You have to know 1/x, right? You have to know that is e to the x, right? E to the x or 2 to the x. Because 0, e to the 0 is 1, and it goes up. When x is less than 1, like, x is less than 0, like negative, e to the negative number is 1/, right? So it's fraction, very small number goes. So you know this one is 1-to-1, but not onto if you cover all. But if the image is all the positive number, it can be also onto. So it depends really. This is very easy to score and very easy to lose mark if you don't look at the domain and codomain very carefully. So you look at the sets that's given, it can change. Doesn't mean that if this is the function, it's always onto, right? So it has to depend on this one. Okay, so these are just the basics. F, okay, we want to say whether, just now we have shown it is a homomorphism, right? I just rewrite this since f of x plus y is 2 to the x plus y, which is 2x to y, which is fx cross fy. You know why I don't like xy? It's not like I don't like xy, but to be in the element of G, because we will get confused with our own handwriting, right? Sometimes we put cross because of this cross or x because of the x. If we get confused with own writing, what about me, yeah? To read your writing. The second one, f is 1-to-1. Say the question is proof that it is an isomorphism. So I know I had to prove this. If you said determine, then we had to check whether, right? Okay, so f of x equal f of y. This is you assume. Okay, so you have to know the definition of 1-to-1. Let fx is fy. Then use the formula. 2 to the x is 2 to the y. This implies, okay, how do you show x equal y from here? Anyone wants to share how? Hannah, you are here, right?
Yes, Prof.
Last time Nabil kata siapa nama kawan dia? Yang dia kirim salam tu?
Afif.
Afif. Hari ni saya nak tanya Afif. Salahkan Nabil because he mentioned your name. Afif, are you here? Ngeri dah Afif. Okay, you take a log, right? Don't tell me you want to blow X jatuh ke bawah. Kan dia macam kat pokok ni. How to get the X and Y di dasar kan? You take log both sides. So sometimes you can put like this. But when you write like your undergraduate project report, you explain, it's not the same as what we put in the class or test, or you had to write in words. So in words, you will say taking log for both sides, giving us, right? Kalau jawapan quiz ke apa, it's okay to put it like this, right? Taking log both sides. We have log, it can be natural log, it can be log this, then any log. Then this will give us, right? X log 2 is Y log 2. Log 2 is a number. You can divide both by log 2 because it won't be 0. So divide by log 2 both sides. So X is Y. Which what we want to show is 1 to 1. Yeah. And then for on 2, 3. Number 3, F is on 2, since then for all Y in E plus, even number, yeah? For all Y in E plus, why do you want to say there exists X in Z plus? Okay. This is the what we want to show, yeah? So what I do is put this aside. I let Y in E plus. Okay, find X in Z plus such that Fx is Y. Ada ke tak ada? Okay, is there an X mapped to Y if you were given the Y? Boleh padam ya? Yes? Okay. Okay. Now, Fx is Y, give 2 to the X is Y. Just copy the formula. How do I get X equal? Because I want to find X, right? How do I get X? How do I get X? The same method. You want to put the X down, so you take log, right? Taking log both sides. So I have taking log both sides. Log 2 to the X is log Y, which give X is, X log 2 is log Y, which give X is log Y over, what is log 2? If you take both log base 2, you have to know your trigonometry or log. Okay, what is log 2 base 2? Takkan nak tekan calculator ke? This is 1, right? So this is log 2y. You have to know whether this is in Z plus or not. Any y in E plus is in the form of 2 to the power, right? Okay, y is always 2 to the k. Because this is even number, right? Y is always 2 to the k. So this is log 2, 2 to the k, which is k, right? Which is k in Z plus. Kecilnya kat ujung. Let me see whether you can see it. Okay. Okay, I repeat, yeah. This is a little bit tricky, although it's not hard, but you have to show it. To show it's onto, okay, to show it's onto, it's like this. This is your G, this is your H, right? Onto means take anything in here, take any Y in here, and this H is E plus. Take any Y in here, you have to show there is this X. Match or map to the Y. Take Y in here, right? Find X in Z plus. Such that F map X to Y. If there is no X, meaning it's not onto, there's something that has no X map to it, or there's something that is not an image, right? And this X has to be inside here. It has to be a part of Z plus. So you take Y in E plus, find X in Z plus, which is mapped to Y. So I just use that. I just take this. Okay, Fx is Y. So what is Fx? Use the formula 2 to the X is Y. You want to solve for X. So the point is solve for X because you want to find X. The calculation should be easy, simple, like your whatever you know, basic math. So taking log, you want to write X in terms of Y and make sure this is in Z plus. So you go up to here. If you just leave here, this does not show this is in Z plus yet. So I take log base 2, so I can get rid of dividing this, dividing 1, right? So this one is log 2, 2. And to show this is in Z plus, I know that if Y is in Z plus, is in E, sorry. If Y is in E plus, even number, plus 2 for Y has to, 2K, sorry. Ada kerut-kerut yang confused. It's not 2 to the K, it's 2K. Okay, barulah macam ada muka yang happy sikit. So K is in Z plus, right? Because E is even number 2, 4, 6, 8. So 2 times 1, 2 times 2, 2 times 3. So it's always 2 times positive. So I have to rewrite this. But this is still okay because log 2 of 2K is log 2, 2 plus log 2K, right? Log 2 of 2K is log 2, 2 plus log 2K. And log 2, 2 is just 1. If you, this is back to the log, the log time. But let me think. Okay, if you put X is log M, I forgot the symbol, but let's just write like this. All I remember is log 2 of 100, log 10 of 100 is 2. This is 100 is 10 squared, right? Is it right? You remember, okay. Because this is log 10 of 10 squared. And then log 10 of 10 is 2, or we can write also like this. Okay, so this is right. So this gives me, compare this, n is m to the x, right? That's the formula. Long time ago we learned this. Yeah. Okay. So if you want to see about log 2 of 2k is x, I had to find the x, right? Log 2y, right? This is you have to show this is in Z class. Okay, bagi your homework lah. Yes. Think a bit about this one because I have to go to the last part. Even if you plug in some numbers, you see, because this is log 2 to the even number. So for all kind of showing it's onto, you can follow the same method. If it is not onto, you just need to find one y that is not an image. Yeah, it's easy to show it is not onto, it's easy. Find one y, like I show you this last time, right? 1, 2, 3. If this is 1, 2, 3, 4, 5, 1 goes to 1, 2, 2 goes to 4. So this is not onto because 2 has no, it's not an image, right? You cannot find, if this is 2, you cannot find x if this is integer. For example, there is no x, x squared is 2, right? X will be square root 2, done. It's not onto. Just find something which is not an image. Okay, I have a question. How many of you have class after this? You have class, any? At 10. Ref, you have class at 10. Ada ke tak ada?
I have at 2 o'clock.
No, my question is, who have class after this at 10?
Okay.
Tak ada ya? Okay, class at 11 is okay because I have a meeting at 10. Normally I will stop like in 1 minute kan, but give me another 5 minutes, yeah? Okay. Normal subgroup, I will start with this, continue tomorrow. Just the last part, I will stop and then continue tomorrow just for like 10 minutes and then we start on the new chapter. The last 2 chapters are just calculation. It does not need the thinking first and write later like this chapter. That's why I go a little bit slow. This is actually the hardest chapter for this class. Not hardest in the sense that hard cannot score, no. Hard meaning it's really abstract. That's why modern algebra in some universities, like my university, it's called abstract algebra. It's very abstract. I didn't say hard as of that kind of height. Yeah, the others is straightforward calculation, right? So after this is straightforward calculation with a little bit of embedding this chapter. So that's why I really want you to understand this chapter, because the next two chapters, some of them they use the method in this chapter. There's a normal subgroup and factor group, which I will repeat again in the last chapter. It has something to do with this. So let G be a group and H a subgroup of G, then H is normal in G if A, H is H, A for all A in G. We write H is no. Okay. This is not English normal, eh? This is modern algebra normal, abstract normal. This means, you remember coset, right? This means left cosets are equal to right cosets. You remember, right? I give you an example to find coset, like for 3z, is it 3z? And then we have 3 cosets, right? I still remember giving it to you. So if the operation is addition, multiplication numbers as normal, the right and left cosets are the same. So that particular subgroup that we talked about before is normal. Yeah. So in this class, we always look at abelian group. So the subgroups that we have for this class, we can see it's normal because I didn't go to matrices. I didn't go to like permutation, right? You learn in modern algebra. So this is just basic to show about normality and to find cosets. So if you have to show a subgroup is normal, you find the left coset, you find the right coset, and you show they are equal. Okay, so that's one last one. I have a meeting. So one question, if there's any. No question? Okay, everything is okay so far? Okay, okay, I don't see any okay. All right. Okay. Okay, okay, okay.